Welcome. We'll take a look at one more example here of estimating a population standard deviation, and this time we'll actually have some data. So I'm going to return to my churros. So Chester claims his churros have a mean of 300 calories with population standard deviation 30 calories. So in the past, we learned to estimate the mean calories in his churros, but now what we'll do is challenge his claim about the population standard deviation being 30, and we'll head out to investigate. All right, so what we'll do is select a random sample of 16 Chester's churros, and I've given the number of calories in each of our churros. We will assume the variable is normally distributed, so that is a requirement in order to continue with this process. And we'll find a 90% confidence interval estimate for the true population standard deviation of calories in all of his churros. All right, so he's claiming sigma is 30, but we would like to estimate that population standard deviation ourselves. All right, so first step, when you're given data, you want to get that into a list. So stat, edit. And then if you'd like to pause for a moment and enter that data. And then we'll continue here. So sample size. So we have our lowercase n. Sorry, let me just switch my color. There we go. N. So lowercase n sample size, we took 16 churros. And for our chi-square distribution, we'll need degrees of freedom, which is n minus 1. So in this case, 16 minus 1, or 15. And we'll find our alpha. So alpha is always 1 minus our confidence level. And in this case, 90% confident. So 1 minus 0.9. I like to put the 0 there. 1 minus 0.90 will be 0.10. And then we'll take our alpha that we got and divide that by 2. And that will be 0.05. And I'm going to start filling in my picture here. So our middle is the confidence level. And then the areas that are shaded there are each alpha over 2. So in our case, 0.05 area there on the left and 0.05 on the right. So those 3 areas add up to 1. So we have our whole graph represented. And then we also need our 1 minus alpha over 2. So let's take care of that. So 1 minus 0.05, that will be 0.95. All right, so we need those numbers so we can go to our table. So we'll go to this column in the table, and it will have a complement column. And that's how we'll find our values of chi-square left and chi-square right. So you can go to your table. I'm just going to scroll up here for a moment. So I've got my chi-square table. I'm just going to circle 0.05 and 0.95. I can see on the table their complements. And because this is on the right side of the table, this column will give you a chi-square right number, and this column will give you a chi-square left number. And we are in particular looking at 15 degrees of freedom. So chi-square left is 7.261. Chi-square right is 24.996. Okay. So this column gives you your chi-square right value, and the other will give you your chi-square left value. All right, so let's get those written down. So that was 7.261 for chi-square left and 24.996 for chi-square right. Okay, now we're ready to continue here to find our confidence interval. And in the case where they give us the data, in order for our answers to match Alex, I'm going to step through the process of what you'll want to do if given data. So we've already taken care of step one. We've entered the data into a list. Now what I'm going to do is run one of our stats. So stat calculate, one of our stats, enter. And by running that, I'm going to get my sample standard deviation. So remember again, this sigma is meaningless here because we didn't enter population data, we entered sample data. So now we know the sample standard deviation. And what I'm going to do is actually continue now and find the variance. So I'm going to find S squared by doing the following. So what we'll do is after running one of our stats, I'm going to get the value S on the home screen. So I'm going to hit my variable button. So we're selecting variables, and then go down to choice 5, statistics. And then choice 3 is the sample standard deviation. And now that will be on our home screen. And we want to square that for our variance. All right, so it says that we want to round our intermediate values to 3 places. So now we can round. So S squared equals 267.533. So by going through that process and continuing, it will make certain that your answers do match Alex. Okay, so let's do it. Let me write the formula here for our confidence interval for the population standard deviation. So it's square root n minus 1 s squared over chi square right. And our value of sigma, our estimate will be that sigma is between those two values, lower limit and upper limit. Okay, so in this case, we have square root. N was 16. So 16 minus 1. And now for s squared, we've already taken the s and squared it. So we're just putting in that value 267.533. So don't square it again. We've already squared it. So s squared is done. And then chi square right, sorry, I forgot what that was. Chi square right, 24.996. All right, and then sigma. And then 16 minus 1. And again, times the 267.533 for the sample variance. And now we'll just divide by chi square left, so 7.261. Okay, so let's get this on the calculator. So I'm going to do square root. And 16 minus 1, you can just type 15, of course, but I'm just going to enter it exactly like I have it there. And then we don't even have to hit multiply. So we'll be able to just enter it again, just like I wrote it, and then divide by 24.99996. All right, and since we're at the final answer stage, we're going to round to 1 decimal place. So 12.7 is our lower limit. And then we'll repeat that same thing. So I'm just going to do this the easy way here. So square root again. The only thing I'll change now for my upper limit is that value 7.261 for the chi-square left. And that is 23.5. All right. So I'm just going to scroll up to the top here. So again, what we're doing here is just making sure, again, our rounding will match Alex. So when it says carry intermediate values to 3 decimal places, we did that. And then our final answer to 1 decimal place. So if you're given data, follow those steps, find your S squared, and then substitute. And then we round it to 1 place. And then finally, we'll end with our sentence. So we can now say, based on a sample of 16 churros, we estimate with 90% confidence that the true population standard deviation of Chester's churros in terms of calories is somewhere between 12.7 calories and 23.5 calories. All right, and there you have it. Hopefully that was helpful.